Imagine this. You step out from the shadow of your legendary teacher Galileo Galilei to solve a puzzle that even he couldn't crack. Well, that's exactly what Evangelista Torricelli did. We're going to dive into the story of this physicist and mathematician who not only figured out how to measure something invisible, but also wrestled with the very idea of infinity itself.
So our story doesn't start in some quiet, pristine laboratory. Nope. It starts with a noisy, messy, real-world engineering problem that had the smartest people of the 17th century completely stumped. This was a mystery that the great Galileo himself had struggled with, and it turned out to be one of the last big challenges he'd pass on to his student. So here was the problem everyone was facing. Miners, engineers, you name it. They all knew that no matter how powerful they built their suction pumps, they just could not lift water any higher than about 10 meters, or around 34 feet. Why? What was this invisible wall they kept hitting?
Now, Galileo, being Galileo, had a theory. He thought that a vacuum created inside the pipe was actually exerting a force, literally pulling the water up. But he figured this force of vacuum must have a limit, kind of like a rope that can only take so much weight before it just snaps. It was a good guess, made sense, but it wasn't the full story.
And this is where Evangelista Torricelli steps onto the scene. In the very last months of Galileo's life, Torricelli became his assistant. And Galileo gave this brilliant young student this exact problem, kind of hoping that he could succeed where the master hadn't.
Now, Torricelli didn't just tweak Galileo's theory, he flipped it completely on its head. He came up with a totally radical new way of looking at the problem. He realized it wasn't about a pull from above, it was about a push from all around us.
And this quote just says it all, doesn't it? What a beautiful, powerful line. He realized that we're all walking around at the bottom of a giant ocean of air, and that air has weight, a lot of it. It wasn't a vacuum pulling the water up into the pipe. It was the incredible weight of the atmosphere pushing down on all the water in the well, which then forced it up into the empty pipe.
Okay, so great idea, but how do you prove it? Well, he came up with this really elegant experiment. So why mercury? Simple. It's about 13 times denser than water, so you don't need a 10-meter tall tube. He filled a glass tube with it, plugged the end, and turned it upside down in a bowl of more mercury. And instead of staying full, the mercury started to drop.
And here it is, the aha moment. The mercury column fell until it was about 76 centimeters high. Now this is the crucial part. That height is almost exactly 1/13 of the 10-meter height of the water. It was perfect proof. The weight of the air could only push up a column of liquid to a certain point, and it all depended on how heavy that liquid was. It was atmospheric pressure, not some force of vacuum. And you know that empty space at the top of the tube? That became the first sustained vacuum ever created, the Torricellian vacuum.
You know, this one experiment just changed everything. Torricelli had literally just invented the mercury barometer. All of a sudden, scientists had a tool to measure air pressure, which became the absolute key to understanding and forecasting the weather. It was a huge, huge deal.
But Torricelli's mind didn't just stop with the physical world. Oh no. He also dove deep into mathematics, where he started playing around with ideas that were honestly just as mind-bending as an invisible ocean of air. He came up with this shape, which we now call Torricelli's trumpet, or sometimes Gabriel's horn. And this thing presented a stunning paradox. It was an object that just seemed to defy all logic, and it kicked off these huge debates among philosophers about what infinity even is.
Okay, so try to picture a trumpet that just keeps on going forever. It gets infinitely thinner, but it never ever ends. So, Torricelli proved that this shape has an infinite surface area. That means if you tried to paint the outside of it, you would literally run out of paint long before you ran out of trumpet to paint.
But, and here's the part that just breaks your brain. Despite that infinite surface, Torricelli also proved that the shape holds a completely finite, totally measurable amount of space inside it.
So this leads to a wild contradiction. You could take one finite can of paint and pour it in and fill the entire trumpet, no problem. But you could never, ever use that same can of paint to coat its infinite outer surface. It's a shape you can fill, but can never paint. How is that possible?
So, this deep dive into infinity wasn't just some mathematical game for Torricelli. For him, it was all connected to this really profound philosophy about how we understand truth itself. I mean, how can our finite little human minds even begin to grasp something that's eternal?
Torricelli had this idea that mathematical objects, like circles or triangles, or even his infinite trumpet, they don't exist somewhere out in the universe just waiting for us to find them. He believed they are born in our minds at the exact moment we define them. They are creations of human thought.
But here's the twist. He also said that once these human-made ideas are proven to be logically sound, they somehow appropriate eternity. They become these timeless, unchangeable truths, almost as if they were handed down from on high.
This just raises a fascinating question, right? If we're just making these things up in our own heads, how do they suddenly get connected to something that's eternal and absolute? Are we discovering truth, or are we creating it?
To explain this, Torricelli used a concept from philosophy called beings of reason. Basically, these are objects that exist purely in our intellect. They're brought into being just by the act of us defining them. They aren't physical things you can touch, but in the universe of the mind, they are very real. And here is his really radical solution. So the traditional view was that our minds are like flashlights, and eternal truths are just out there in the dark waiting for us to shine a light on them and discover them. Torricelli said, no, that's not quite right. He argued our minds are more like a sculptor's chisel. The eternal truths are like a raw, formless block of marble, and by creating our beings of reason, we are the ones who give these truths their final, concrete shape. We're not just finding truth, we're actually participating in completing it.
So where does all this leave Torricelli? Was he just Galileo's really smart student, or was he something more? How did the people of his own time see him?
Decades after his untimely death, he was only 39, his contemporaries published this anagram of his Latin name. It translates to, "Here blossoms another Galileo." I mean, they didn't see him as a footnote at all. They saw him as an intellectual giant, a true successor to the great master.
And it's pretty easy to see why. The man solved a fundamental problem in physics. He invented a crucial scientific tool. He pioneered the totally mind-bending math of infinity, and he proposed a radical new philosophy of how we even know what's true. That is quite a resume.
You know, Torricelli's work really leaves us with this deep question that's just as powerful today as it was then. When we do science or math, are we just describing the universe? Are we just uncovering the rules of a game that's already been set up? Or, by defining our concepts and creating our tools, are we somehow helping to create reality itself? It's a question Torricelli dared to ask almost 400 years ago, and one we're absolutely still wrestling with today.